So I'm just going to give a really quick rundown on how I got up and running so far with the OCaml shit. You've probably done the REPL already in Terminal. I would highly recommend doing a lot of Terminal just to get familiar with it because this teacher is really on it about the Terminal. I was just going to show you kind of how I'm getting set up and how I've got it to work so far. I know you're doing the online editor, but when you come to the file, I was going to show you my environment that I kind of set up. So I talked to another classmate. He highly recommended use Sublime Text. I tried using Atom, but it's kind of just, I don't know, it was more complicated than I needed it to be. Sublime Text is free and very simple to work with. And you can install the OCaml package quite easily. So if you go to Sublime Text, Preferences, Package Control, and then in here you type install package, then it'll access the package management thing. And you can just type OCaml. And then I just installed this one right here. And then I think that's it. I don't think I did anything else. That's all, right? So as you can see, the syntax highlighting works back here. And, it works. It just works, right? That's what we need. As to the files, so if you FTP into the server, so the best way to do it is you go to his homepage for the course, you go to assignments, and then you go to the OCaml section, right? And then if you copy that AFS, here, let me actually just do it right now. Right, just do this real quick. Course material, assignments. This directory right here. This directory is the one you want, and then you can even do put this in there, and then right. So here you're in the timeshare CD. Just paste that giant piece of shit in there, and then if you do ls, you see assignment 2 OCaml. So CD ASG2. -OCaml. So you just go in here with FileZilla and then just copy that whole folder, and you can see there's a bunch of shit in here, right? So anyways, that's, you know how to do that. So I'll just terminate that. So once you're in there, once you have the folder, you're going to copy it over onto your local desktop so you can edit it. It'll look just like this. Go inside, there's code. So the code has some, these files right here, CMI and CMO files. You want to delete all of these because they will prevent the program from running correctly. They're kind of like object files for C, so they're machine code, but they're for a Unix operating system that's not compatible with Mac. So it's highly specific to where it was compiled on, which is the timeshare, which is not where you'll be working. So just delete them, it'll be fine. And then once you've done that, you can go into this directory. So what is this? Right, so now we're in there. I got all this shit. As you can see, I have these 3 files here open over here, and these are the main program files for the program. So we're going to be editing these. I'm assuming that everything he's done pretty much works. I think these files, as they are now, are what were compiled to make this OCaml DC program right here. So, for instance, if I call /OCaml DC in this directory, it will start that program. And there are some sample functions like you type a number and you hit enter and it gets pushed onto the stack. That's the way it works. So the stack just grows as you add the numbers to it, right? So all these numbers, it doesn't look like anything's happening, but each time I hit enter, they're getting pushed to the stack, right? And he has implemented the print stack function already, which is F. So you hit F, and then it'll print everything that's on the stack. So you see 45 is at the top because I just pushed 45. Now if I put the plus operator in here, then it will perform the operation. It doesn't tell you that you did it, but it does it, right? So if I press F again, 70, right? So it took the first 2 things of the stack and then it applied plus to them, and then it came out 70, right? So it works just like you think it would, but not everything's implemented yet. So I can hit 45 and then minus, and that should be 70 minus 45 or something, right? but when I print it out, it's actually plus because subtraction isn't built in yet. So like you can see that in this main like kind of factory execute thing that he made here. It calls bigint.sub, which is a sub function of bigint.ml. But you can see that like everything is set to just be add here. There's no any other functions besides add. So they're all just like default, just adding operands. So we need to implement all of this right here, this whole thing. And that's what we'll be doing. So here's add that he already did. So all we need to do is just write our functions in this namespace and then put them in right here, and it should function. Everything should work right. We shouldn't have to fuck with anything. So it's actually not too bad once we can figure out how to do this part, which will be complicated. So what else? Oh yeah, so I was going to say how I'm planning on doing this. So let me go open a new terminal. Actually, right-click services. This is a handy thing I did so I can open a new terminal at a folder. I don't have to do CD a bunch of times. But you can do aliases. There's like things you can do with scripts if you want to not have to type a bunch on the terminal. But you know, it's worth the investment once you figure out how to do it. And if you use the shit a lot, it's really worth it. So I can just do OCaml to start up the interpreter here, and then since I'm in this directory here, right? In the code directory, I can access this file here, dc.ml, and it has instructions. You just type #use dc.ml, right? And then you have to put the things. You have to do a string. #use dc.ml, right? String, and then the things. That's stupid. Hang on. DC. I put comma. Silly. All right. Thanks. Yeah. So like that giant flash of shit, it just loaded the entire program. Like all those programs that are defined. That's really weird. Anyways, you don't need to worry about that. So everything that's in main.dc.ml just got loaded. So all these functions are in there. Bigint.ml is all loaded as well. So we can now access the data, and all we have to do is just re-enter that. Anytime we make a change in this file, we can change this file, re-enter that #use command, which you actually need to. There's another thing I should probably show you. So you have to type rlwrap. So you have to brew install rlwrap. So brew install rlwrap, and I already have it, so it shouldn't really do anything. But when you install rlwrap, it lets you use like typical Unix code completion stuff in the terminal. So like I can press up arrow and it'll go through all my recently used commands. You can't normally do that in OCaml. It just bitches. Well, this one had rlwrap running, so it works. But like in this one, you can't. Like when I push up arrow, it just gives me this garbage, right? Which it doesn't do anything. So it's fucking annoying. But anyways, yeah. I already have it, right? So it's fine. So you just type rlwrap OCaml, and then it works. And I can type like let a equal 5, right? And then I can, there you go. I can code complete it, which is really handy. So all you really need to do is just like type #use, and then you can get in a really easy like click this button 50 times loop and not have to worry about like entering a bunch of complicated ass commands. So that's like basically my plan of attack right now, is to fuck with these functions until they work right, and then just run it in the terminal and, you know, hope it works. I think that's about it. And then, you know, once it all works, then we'll run the makefile, and then it will compile into a new OCaml DC. I think that's all we have to do. Oh yeah, and then the general strategy. Subtraction, we basically need to just figure that one out, but then after that it should be easy. Like multiplication is going to be just like adding multiple times. We could always implement it like that. Like if we're multiplying 75 times 25, we could just add 75 to 75 25 times. And that's the same thing as multiplying in a like really shitty, unoptimized way, but like, you know, that'll probably be enough to pass the programming assignment. Division is the same, but with subtraction. So we're just subtracting the number however many times, you know. And then the remainder will just be like whatever's left after we divide. And then power is just repeated multiplication. So basically, once we figure out subtraction, we can implement the rest in terms of these first two, which really should not be that bad at all. Yeah, so that's it. I just wanted to make this video so that I could kind of like get you up to speed on what I've done, and